Non-parametric statistics already we have been discussed in the last video also. Under this non-parametric static distribution free statistics make few or no assumptions about the underlying distributions of the data. Distribution free means make few or no assumptions about the underlying distribution of the data. No assumptions. This is a very important point. Let's try here distribution free statistics. Sign test. Here sign test mentioning means plus or minus testing. That's all. Well, analog to the one sample t test and is used to test whether a sample has a hypothesis median. Analog to the one sample t test, is used to test whether a sample has a hypothesis median. So data values in the sample are classified as above plus or minus, above plus or below minus, above, below hypothesis median. Under the null hypothesis that the sample is drawn under the null hypothesis that the sample is drawn from a population with the specified median. This classification have a binomial distribution with pi equal to 0.5 probability of the population under the null hypothesis. Under the null hypothesis that the sample is drawn from the population. Under the null hypothesis that the sample is drawn from the population with the specified median. This classification have a binomial distribution with pi equal to 0.5 probability of the population. Z equal to x plus or minus 0.5 minus np divided root of np into 1 minus p. Okay, where x is the number of the observed values greater than median. 0.5 is the continuity correction. 0.5 is the continuity correction. Negative in this case for hypothesis. Pi is greater than 0.5. NP is the median of the binomial distribution. The expected value for x if the null hypothesis is true, and the denominator is the standard deviation of the binomial distribution. This x number of observed values. A number of observed values plus pi equal to here 0.5. This is the 0.5 here continue correction. Negative in this case, pi is greater than 0.5. Negative in this case. Okay. To be added, then NP is the mean of the binomial distribution. mean of the binomial distribution. So here expected value plus pi, that is 0.5 plus or minus. After getting this value, we have to subtract it from here NP, that is binomial mean of the binomial distribution. Binomial distribution subtract from observed values. Binomial, the expected value for x if null hypothesis is true. NP is the mean of the binomial distribution. The expected value x if null hypothesis is true, then only NP is the binomial distribution, mean of the binomial distribution. The expected value for x if the null value is true. Okay, and the denominator is the standard deviation. Standard deviation of the binomial distribution. So what we are doing here, expected value plus 0.5 plus 5, add or subtract. In negative sense, in negative case we have to subtract here. In positive case we are adding here. Then how much getting? That value subtracted by NP, that is mean of the binomial distribution. Then the denominator standard deviation of the binomial distribution. What we are doing here, NP multiplying, that is sample, number of samples, multiplication with the probability. Okay, and then we have to, what we are doing, how much probability is there, we have to subtract with the 1. Then how much we are getting, we have to multiply with this. After multiplying, we have to reduce that value by root, not squaring but root. Here also NP, number of samples, probability, multiplying, and then deduct from this expected value plus pi plus or minus pi. After this value divided from this value, then we will get the result. Now we are going to discuss about some related questions. Design an experiment to see whether a new feature is better. Questions: how often y occurs? Do x and y covary? Requires measuring x and y. Does x cos y? Requires measuring x and y and measuring x and accounting for other independent variables. Require measuring x and y and measuring x and accounting other independent variables. We have goals for visitors. Sign up by metrics to improve visit time, revenue, return. We are manipulating independent variables independent of what the user does. To measure dependent variables, what the user does. We can test two versions with the A/B test, A by B test, or many full versions of a single page. How different web pages perform using random sample of visitor. Define what percentage of the visitor are included in the experiment. Choose which object to test. Mean standard deviation of two blended datasets for which you know their means and standard deviations. The difference between the means of two samples A and B, both randomly drawn from the same normally distributed source population, belongs to normally distributed sampling distribution whose overall mean is equal to 0 and whose standard deviation, that is standard error, is equal to this one, where SD square is the variance of the source population. SD standard deviation divided by NA SD square divided by NB, number of samples. Standard deviation to be square divided with, that is here SD square, variance of the source population, variance of the source population, variance of the source population, then divided by NA, and then in NP side 2 sample, no, that's why A 1 sample, B 1 sample, then that variance of the source population to be what doing, squaring, then divided with the variance of the, yeah, that is population of the A samples, then we will get the result. Then what we are doing after that in P sample, same doing here, SD square divided by NP, then how much you are get, this value and this value to be add, then what we are doing after add, then we are going to reducing, that is scaling, scaling, it means reducing down. So if each of the two coefficient estimates in a regression model is statistically significant, do you expect the test of both together is still significant? The primary results of a regression analysis is a set of estimates of the regression coefficients. These estimates are made by finding values for the coefficients that make the average residuals zero and the standard deviation of the residual term as small as possible. In order to see if there is a evidence supporting the inclusion of the variable in the model, we start by hypothesizing that it is does not belong, that it is true regression coefficient is 0. Dividing the estimated coefficient by the standard error of the coefficient yields the t ratio of the variable, which simply show how many standard deviations worth of sampling error would have to occur in order to yield an estimated coefficients so different from the hypothesis true value of 0. What the relative importance of variations in the explanatory variables is in explaining observed variation in the dependent variable. The beta weights of the explanatory variables can be compared. What the relative importance of variations in the explanatory variables is in explaining observed variation in the dependent variable. The beta weights of the explanatory variables can be compared. Best weights are regression coefficients for standardized data. Beta is the average amount by which the dependent variable increases when the independent variable increases. One standard deviation and other independent variables held constant. The ratio of the beta weight is the ratio of the predictive importance of the independent variable.